Hello students, how are you all? I hope you are doing absolutely well. So today let us start with some of the questions that is belonging to your chapter, that is periodic classification of the elements, and today we are going to discuss about some of the questions that are from your NTSE and other competitive exams point of view. So let's have a discussion about few of this question. So let us move to our first question. Our first question in this series will be correct order of the ionization potential of these elements. Now, I have discussed earlier that such type of the questions are usually asked in the exam about the increasing decreasing order in the periodic property. It means about the periodic trend. So, we have to arrange these elements in the order of their ionization potential. So, firstly, let us have a look at these elements: boron, carbon, aluminium and silicon. Now, these are the elements that basically belongs to the group number 5 of the boron. That is, these elements we have to arrange in the order of ionization enthalpies. Now, what we have observed that as we are moving left to right, the ionization potential increases. But if I am going from top to bottom, the ionization enthalpy generally decreases. So these are the actually elements in the along the group. So we are arranging these elements according to this. So if going from top to bottom, the ionization enthalpy decreases, so it will be minimum for aluminium, then after silicon, then after boron, then after carbon. So this will be the order of ionization and enthalpy. Now, why this is order? Let us assume the modern periodic table here. We can see that boron lies here, carbon lies here, aluminium lies here, silicon lies here. So this is the observation in the group. This is our group number 3 and this is our group number 4. Now you can see that if I am talking about the ionization enthalpies, from left to right in the periodic table, ionization enthalpy increases. But if I am moving from top to bottom, the ionization enthalpy will going to be decreased. So if we are going to arrange elements according to the increasing ionization potential, so you can easily observe that it is less for aluminium, then it will be less for silicon, then it will be less for boron and it will be maximum for carbon, because in going from left to right, the ionization increasing energy is going to be increased, and this increases just because the atomic size decreased and the effective nuclear charge is going to be increased. So this is the trend. So I can see here that option number D is the correct answer of this question. Now, let us move to our next question. Element X, which is a solid having a high melting point, is going to form a chloride, XCl3, and this element would be in the group of which group of the periodic table? Now, let us go through each step one by one. So, firstly, I am writing that element X is a solid. So, what is element X? Element X is a solid having a high melting point. It means element is having a high melting point. Now, it is from a chloride having a formula XCl3. Chloride formula XCl3. And this element X would be in which group of the periodic table? Now, you can see that it is forming a chloride. It is forming a chloride. So, if I am going to find out the oxidation state of X will be X plus 3 into minus 1 equal to 0, because chlorine will have a electronegativity and have a charge of minus 1. So, it came out to be 3. Now, this 3 will be the number of valence electrons. So, we can see that number of valence electron will be 3. Now, if I am going through each options here, we can see that for the sodium we have the 1 valence electron, then magnesium we have 2 valence electron, then aluminium we have 3 valence electron, and for the silicon we have 4 valence electron. So the condition which is going to satisfy here, that 3 valence electron and these electrons are for the aluminium only. So the compounds it is going to form will be AlCl3, that is aluminium chloride. So the condition here satisfied only for aluminium. So we can say that here option C is correct. Here option C is correct. So this will be the solution for our problem number 2. Let's copy it from here. Now proceeding to the next question, we have arrange the following elements in the order of their increasing ionization energies. Increasing ionization energies, once again I am repeating, as we move from left to right in the periodic table, ionization energy decreases, but if I am going from top to bottom, the ionization energy will going to be decreased. So let's have a look at this question. If I am moving from left to right, if I am moving from left to right and if I am moving from top to bottom, what will be the trend in the ionization enthalpy? From moving from left to right, the ionization enthalpy increases. But in moving from top to bottom, the ionization enthalpy decreases. Now, what are the elements we are provided here? We are given O, S, Se, Te and Po. These are the elements we have provided. Now, this is group number. Which is the group number it is going to represent? It is going to represent the group number for the oxygen, that is 6. Oxygen, sulfur, selenium, tellurium and the polonium. These are the elements and these are the elements along the group. These are the elements along the group. So along the group we can see that the trend in the ionization enthalpy will going to be decreased. So the trend will be this ionization enthalpy will be minimum for polonium and it will be maximum for oxygen. So we can see that it is minimum for polonium and it is maximum for oxygen, and the elements are arranged in the similar way. These are the group number elements. So in moving from top to bottom, ionization enthalpy decreases. So it will be maximum for oxygen and it will be minimum for polonium. So increasing trend will be from least to the highest element. So it will be the least for polonium and it will be maximum for the oxygen. So it will be polonium, tellurium, selenium, sulfur and oxygen. So which option is correct here? Option number C will be the correct, because from going from top to bottom, the ionization enthalpy will going to be decreased. This will be the explanation for this question. Now, let us move to our next question. In the periodic table, generally following similarity is found in the same group. So, in the description about the chapter, we have seen that the period will going to tell you about the number of shells and the group will going to tell us about the number of the valence electron. So, let's check options here. In periodic table, similarity is found in atomic number. It will not be in the atomic number. Number of electrons in the outermost shell of an orbit. So, this will be the correct answer, because in moving down the group, we can see that similarity in the group has been found in case of the number of valence electrons only. So, here option number B will be correct. Now, proceeding to the next question, we have what is the correct order of the increasing acidic strength? Now, you can see that in moving from left to right in the periodic table, the acidic character is increases from basic to acidic, and we have amphoteric oxides too, so which are going to show the properties of both metal and non-metal. So let's have a look at the increasing acidic nature. So which acids are provided here? Sulfur dioxide, SiO2, P2O3 and Al2O3. Now, how can we determine the acidic strength of a compound? So you can see that acidic strength of a compound is basically determined by more the number of oxygen atoms, more will be the acidic strength. And secondly, in moving from left to right in the periodic table, acidic strength will going to be increased. So what will happen? We can write here more number of oxygen, more will be acidic character. One property is this, but it is for similar elements. And the second property here will be as we move from left to right, we move from left to right in the periodic table. It means if we are moving along the period, if I am going along the period, the acidic character will going to be increased. So what will happen? Acidic character will increase. Acidic character increases. Now you can see that these elements, that is sulfur, silicon, phosphorus and aluminium, this is having atomic number 13, this is having atomic number 14, this is having atomic number 15 and this is having atomic number 16. So it will be increased from 13, 14, 15, 16. So among all these options, you can see that sulfur is the most acidic. So if I am going to arrange these compounds, we can found that sulfur will be more acidic. Then after, we can see that after sulfur, we have the 15th number element, that is P2O3. So P2O3 will be lie here. So P2O3 will be less acidic. Next, moving to the next compound, we have among SiO2 and Al2O3. Now, let's go through this statement here. We can see that in case of Al2O3 and SiO2, this is going to form the amphoteric oxide. This is going to form the amphoteric oxide. So then after we have Al2O3 and then after SiO2. So what will be the trend next here? We will have SiO2 and then we will have Al2O3. So it will be the number according to 13, 14, 15 and 16. So we can say that sulfur dioxide is going to be more acidic. So which option is correct here? So according to this sequence, we have the correct option here, that is option number C. So we can see that option number C will be the correct explanation here. Al2O3 will be the least, then SiO2, then P2O3, then sulfur dioxide is the more acidic. Now let us move to the next question. Which one of the following is not a periodic property? So let's see options here. Electronegative, it is a periodic property we have discussed earlier. Atomic volume, it is again periodic property. Ionization potential, it is again the periodic property, because these properties are basically depends upon the electronic configuration. So they are periodic properties. Now among all these options, radioactivity is not a periodic property. Radioactivity, refractive index and the specific heat of a substance will not to be counted in the periodic property. So radioactivity here will not be a periodic property. Now let us move to the next question. In the modern periodic table, arrange the third row elements in the increasing order of their atomic size. We have to arrange the elements in the increasing order of atomic size. So we have elements here. So first write the elements here. Sodium, magnesium, aluminium and silicon. So what will happen here? As we move from left to right in the periodic table, the atomic size will decrease. Atomic size is decreasing because no new shells are found for adding much electrons. So what will happen? As we move from left to right, as I move from left to right in the periodic table, it means I am moving along the period. I am moving along the period. As I am going along the period, what will happen? Atomic size decreases. Atomic size decreases. Now, we can see that sodium is having atomic number 11, magnesium 12, aluminium 13 and silicon 14. So, if I am going from left to right, which is going to possess the highest or the largest atomic size? Sodium is going to have a largest atomic size. So, we can see here sodium is having a largest atomic size, then after magnesium, then after aluminium, and the least size is for silicon. So, you can see that atomic size decreases as we move from left to right. So, which will be the correct option here? Sodium, magnesium, aluminium and silicon. So, we have the correct option here, that is option number A. So, if you are going from left to right in the periodic table, the atomic size is going to be decreased. Now, let us move to the next question. Which of the following element belong to the lanthanoid series? Ce cerium, Hg mercury, Th thorium and Mn manganese. So, among the following metal, the lanthanoid metal, it means the lanthanoid series is going to be start from cerium. So, the option number A will be the correct. Let us proceed to the next question. D block elements are. So, we have discussed in the chapter that D block elements are known as transition elements and F block elements are known as inner transition elements. So, the correct option here will be D block, that is they are transition elements. Now, let us move to the next question. On going from left to right in the periodic table. Now, read the question carefully and go through each step one by one. The question is saying that we are going left to right in the period. So, what we are doing here? We are going left to right in a period. In a period, we are going from left to right. The size of the atom decreases. The size of the atom decreases. So, the second step is size of atom decreases. But the size of the noble gases is greater than the size of the other elements. So, you can see that noble gases size is greater than other elements. Now, what it is going to specify here, in the chapter we have discussed about the three type of the radius, that is covalent, ionic and the van der Waals radius. So, I have told you that the elements, that is the noble gases, are going to exhibit the van der Waals radius because they are not forming the covalent bond here. So, we can count the van der Waals radius in case of the noble gas element, and due to this radius they have the larger size as compared to the other metals here. So, among these options, the correct answer will be less reactivity, measurement of van der Waals radius, absence of any valence electron or the effective nuclear charge. So, the measurement of the van der Waals radius will be the great explanation for the larger size of the noble gases. Now, move to the next question. The bond in a compound formed from the combination of group 14 and 17 group elements. Now, we have to take a bond formation in group 14 and group 17 element. Now you have to analyze the bond that is formed from the combination of group 14 and group 17 elements. You know that group 14 element constitute of carbon compounds. Group 17 is actually halogens. Now we know that the group number 14 compounds will going to form only the covalent bond, because the carbon, silicon, these compounds, these elements have a tendency to form a covalent bond. So the options here are electrovalent bond, coordinate bond, van der Waals bond and the covalent bond. So the correct option here will be covalent bond. So the covalent bond is formed from the combination of group 14 and group 17 elements. Now let us move to the next question, but let me clear the board first so we can write the description of the next question here. An element A belongs to the third period. We have an element A. We are given an element A and it belongs to the third period. Third period and second group. Now we have to identify the number of valence electrons in the element. So we have discussed in the chapter the number of valence electrons in an atom is equal to its group number. So you have to remember this, number of valence electron will be equal to group number. So the number of valence electron will tell us about the group number. So here the group number is 2. So we can say that number of valence electron will be 2. So the correct option here will be option number B. Now let us move to the next question. Which pair of the atomic number represents the elements in the same group? So what we have given here, 11 and 19. So we do not have a 19 group here, it must be 9 here. So it may be group number 9. 11 and 9, 6 and 12, 4 and 16, 8 and 17. So the atomic number which are representing the same group will be 11 and 9 only. So the correct option here will be 11, 9. Now let us move to the next group. Which of the following is considered to be the anomalous pair of elements in the Mendeleev's periodic table according to the atomic weight? We have seen that in the Mendeleev's periodic table, some of the elements are arranged whose atomic weight is greater as compared to the other element. So the options here are sodium and potassium, hydrogen and helium, tellurium and iodine, and iron and cobalt. So among all these options, tellurium and iodine will show the anomalous behavior. It means tellurium is arranged before iodine and it is having a greater atomic weight as compared to iodine. So here option number C is correct. Now let us have our next question. Periodicity in the period of the element in the modern periodic table is due to. Now the cause of the periodicity that we have discussed about the trends in the periodic table is just only because of the one factor, that is electronic configuration. So let's check the option here. Regular increase in the atomic weight, periodicity in the electronic configuration, successive increase in the atomic number, and existence of the families of the elements. So among all these options, we have to choose the electronic configuration. So the periodicity arises only just because of the electronic configuration. Now let us move to the next question. We have X, Y and Z are the three elements. So write the step-by-step sequence of this question. We have three elements X, Y and Z. Now these will belong to, each one belongs to any of the groups 1A, 2A and 5th. It may be belong to any group 1A, 3A and 5A. It can be belong to any of the group, and these are the elements here. These are elements here, and there we are provided with the groups. Now what we have to do is, the oxide of X is amphoteric in nature. So let's write the properties here. X is amphoteric. Y is highly acidic. Y is highly acidic. And Z is basic. Z is basic. So we are given a 3 compounds and their nature of acidity and basicity. Now we have to identify the group number. So we know that if we are given a group, if we move from left to right in the periodic table, what is going to be increased? Acidic character will going to be increased. So if I am moving from left to right, acidic character increases. But if I am moving from top to bottom, if I am going from top to bottom, which character is going to increase? Basic character will going to be increased. So we can see that if I am going to arrange these compounds, the first one will be highly acidic, then in the middle we have the amphoteric oxides, and then we have the basic oxide. So this Z will be belong to the 5th group, this will be belong to the 1st group, and this will going to be belong to the 3rd group. So the correct sequence here will be, we have X is for 1A, Y is for 3A, and it is for the 5A. Now we have to arrange according to the basic, according to the elements to which these X, Y, Z belong to. So this X will be going to be belong to the 1, and this will belong to the 3rd group, and this Z is going to be belong to the 5th group. So the correct sequence we have here will be, so the amphoteric oxide we have in the middle one, that is the X, and highly acidic will be Y. So the correct option here will be 3A, 1A and 5A, because the first period is more acidic as we are going from top to bottom. So the correct answer here will be 3A, 5A and 1A. This will be the correct option for having a highly acidic, highly basic or amphoteric nature. Now we have our next question. The noble gas which occur most abundantly in the atmosphere. So the gas which occur most abundantly in the atmosphere will be argon. So the options here are helium, neon, argon and krypton. So the only gas that is found in abundant is argon. This is the most abundant noble gas which is found in nature. Let's have a look at the next question. Which of the following order of ionic radii is represented completely? So, if I am going to consider about the ionic radii in case of cations and anions, what will be the order of ionic radii here? We know that anion will have a largest ionic radii. Anion will be largest, then in the middle we have the parent atom, and then here will be the cation which have the smallest size as compared to the parent atom. Now, what will be the order here? Anion will be the largest in size as compared to parent atom, and parent atom will be greater than cation because cation are the smallest. These are small in size and anions are actually big in size. So, this is the trend we have seen here. Now, analyze the following compounds here. First one is H negative, H positive, H. So, this will not be a correct option because the parent atom is placed in the last. So, this option is a wrong one. Next element, sodium positive, largest. It means cation is going to be large. Again, this option is wrong. Move to the next question. F negative, Na positive, O2 negative. So, electronegative element, then in the middle cation, again this statement is wrong. So, we are left with only one option here. It means this is an ion, this is parent atom and this is cation. Cation will always be smaller in size as compared to the parent atom, and anion will be the greatest in size. So, which option is correct here? We have option number D correct. So, the correct option here will be option number D. It means anion is having a largest size. Now let us move to the next question. Which of the following statement is incorrect about the trends when going from left to right in the periodic table? What we are doing? We are going from left to right. Now we have to identify the incorrect statement here. The number of valence electron increases. So this is a right statement. Atom lose their electrons more easily. This statement is not true. Atom will not going to lose their electrons more easily, because in going from left to right, the atomic size usually decreases. So this is a wrong statement. Oxides become more acidic. Acidic character increases in moving from left to right. Element become less metallic. This is again true statement, because in going from left to right, non-metallic character increases, it means metallic character decreases. So again this is the right statement. So among all these options, we have a correct option, that is option number B here, which is incorrect. Atom is not going to lose their electrons more easily in left to right. Now let us move to the next question. We have an element X forms a sodium chloride having a formula that is HCl2. Sodium chloride is forming a formula HCl2, solid chloride, sorry. It is having a high melting point. What it have? It has a high melting point. Then to which group of the periodic table X belongs to? So if I have to analyze the periodic, it means I have to analyze the group number. What I have to do is, I have to count the number of valence electron. So the number of valence electron in this case will be came out to be 2. So the number of valence electron will give you the group number. So the group number here will be second group. So the second group element will going to form the compound HCl2. Now let us have a next question here. Which of the following is smallest in size? Now among the elements, that is cations and anions, we have to analyze the smallest size. So first one we are provided with N positive, second one is O2 negative, this is F negative, and this is N positive. So we have to identify the smallest among these. So you can easily see that these are anions. Why these are anions? Because they have the negative charge on them. Now these two are cations we have. These two are cations. So we are provided with two options only now, N plus and sodium plus. This is N plus and this is Na plus. Now among these two options, we have to analyze the smallest size. So if I am going to analyze the smallest size, we can see that sodium plus, as we are moving from left to right in the periodic table, size decreases. So the correct option here will be sodium positive. So the smallest size will be of Na positive. So here we have discussed some of the NTSE questions that are very important from your competitive exam point of view. So you have seen these questions and you have analyzed that the questions are usually asked from the periodic trend in the periodic table. So go through these questions very deeply, analyze the periodic table step by step and try to learn the trends in the periodic table. So these questions are over for today. Thank you so much and have a nice day.